but most of our triangles are not. So if you can have a marker ready, and feel free, if you have a marker or a pen, you make corrections, right? You fill in whatever, because you get these back, and then you at least know, okay, it was supposed to look like this, right? It's a quick study tool. All right. I'm gonna grab my highlighters here because I feel like it's always a good idea to do that. So you might be like, oh, there's a straight line there, but that's not the one you want to focus on. You want to focus on this straight line. So if this is 120, you know that that inside is 60. Same thing here. It's a straight angle. This is 120. You know that inside here is 60, right? And 60. And you're like, okay, two 60s, that's 120. This has to be 60, right? Or you can call this angle A, right? And just go ahead and do your 180, right? Minus 60 minus 60. Nothing wrong with that, right? If you need to show your work like that, you go for it. But this is definitely equilateral, right? You don't need any sides, the three angles. If you have all three angles, you're good to go. You don't need to find a single side when it comes to classifying, right? So we actually prefer all angles because it's quicker. Acute equilateral is still good to go. If you didn't show this here, that's fine. I think I would like to see, though, that you came up with these two and then that third one, right? Like show some trail. And let's keep going here. This one you don't have a single angle, right? So this one is worth 3 marks. Okay. So you're gonna have to investigate a little bit. It looks obtuse. You can't just assume because I give you enough information to find out for sure. So let's call this angle A or angle X, right? We're gonna investigate. Is this is the largest angle? You can make two conclusions. If it's obtuse, obviously it's obtuse. If this is acute, you know the whole triangle is acute because there's no angle bigger than this one, right? So you're ruling out things. So let's see here. Side, side, side. So cosine of A would be 4 squared plus 3 squared. I use nice and easy numbers here. Okay. 16 and 9 is 25 minus 36. That's minus 9, right? Am I off? 20, this is 25, right? This is 36. Yeah, that's 5 and 6, that's 11. Sorry. Oops. 2 times 8, 2 times 4 is 8, times 3 is 24. You can stop there though because of this, right? You can make this, you know for sure it's going to be obtuse. It's an obtuse angle due to that negative. You can stop there and just say this is obtuse based on angle, and sides is for sure a scalene, right? That one you know, because also you could have actually said, yeah, I know it's scalene, but is it obtuse or is it acute? Is it right? We need to figure that out. We need to narrow it down, and that's where this. So I would say you get a mark for this, like coming up with a negative, or if you actually solve for the angle. Anybody know what the angle actually is? Or did you stop there? Yeah. 117. So I'll just make a note here. Obviously, there should be more work. 117.28. Thank you. So if you want to do that, sure, why not? It doesn't hurt, right? But I allow you to stop as long as you make a remark on the negative, right? Make a little note. I know this angle is obtuse. I don't know if it's 91, 92, 93, 179. I don't know, but it's obtuse, right? And so 1 mark for each of these then. So 1, 2, 3 for that one. I didn't talk enough about this. I'm going to use this time. Let's make a note here. If you ever have 0 over something, let's just put a number sign here. If the top number is 0 and you have something here, you in fact have 0, okay? If you ever come, like if you get 0 over 24, you know this whole thing is actually 0, okay? And I don't know if you remember what cosine inverse of 0 is, because that's what it would be, right? Shift cos of 0 is 90 degrees. Okay? So if that ever happens, if you get a 0 here, you can also just conclude that this is a right. This would have been a right scalene triangle. Okay, so keep that in mind. So much to know, right? When I sit down and I make my ACs, I want you to think, right? I want to know, right? Are you grasping the concept? I don't want to just wait for the test and be like, hey, right? I want you to already come across that a couple of times before the test. So not the last time you're going to see that. Next, this one. So it's a right triangle. Sure, I can say it's right, but I can't say for sure if it's scalene, if it's isosceles. I don't know, right? So you got to do some math here. Let's call this x. It's one of the legs, right? So you take the hypotenuse. I hope this worked out because I actually just did this on scrap paper. I wanted it to be isosceles, so I hope that works out. So that would be, just do this, minus 81. It's 81.052 and so forth. Take the root of that. Yes, okay. 9.00, right? If you round to 2 decimals. And you realize, hey, these are the same, right? So this is an isosceles triangle. So round to 2 decimals, and if it matches, we're good to go. So I would give you 2 marks for this because Pythagorean theorem isn't that complicated, right? If you just guessed, I would take off a mark, okay? Because just guessing would be kind of hard to guess, right? What else can I say about this? Listen carefully, if the question asks you to round to the nearest whole number, then obviously you'll follow the instructions, right? So let's say this would have been 8.7 something, and I ask you always round to the nearest whole, then you round that to 9, and then you make your decision based on that, okay? So, but if nothing is said, then it's always 2 decimals, right? What is this page? Wait, this page is worth 7 if you want to kind of keep track of your, and if you're watching this, you don't have the AC, come and ask me for a copy, okay? That way you can at least try it on your own. Next, this one is worth 4 marks. So you've got 2 sides and 1 angle. Not enough information to make a conclusion. So when you see a pair, right, just go for it and use sine law, right? So sine of 55 over 200, sine of A, right, whatever that letter is, that's the angle across that side. So let's figure that out. Sine of A is 229.43 times sine of 55 divided by 200. Angle A will be sine inverse of all of this. .9396, so forth. Take the inverse of that, and that's yeah, I wanted it to be 70. This rounds to 70, all right? Because this 9 turns into a 10, 10, 10, 7, right? I will just make a note. So 70. So that means that angle C is 180 minus 55 minus 70. Sorry. And that is 55, right? So this is 55 and this is 70, and you're like, wait a minute, 55, 55. you can actually conclude that this side is 200. Even if you did the math, you still come up with 200, right? So you don't need to, no need for this. You're done because of this. So we're going to say that this is an acute that you should get regardless of whether or not you round it, right? Correctly. You should conclude that it's acute, and we would say isosceles. And for today, because I'm a nice guy, if you didn't round this correctly and therefore missed this, we'll just take off half a mark today, right? Because you're still, so you would then get a scalene triangle, right? Technically, if this was, you would not quite get 55 on both of these. So half a mark off for that. These are fun once you know what you're doing, right? If you don't know what you're doing, frustrating, right? Keep going. I want you to sketch and be very specific. Acute scalene. So I'm just going to make it look a little off-centered because scalene tells me that all three sides are different. And scalene, I'll just go like this. I would accept something like that, to be honest. I'd be fine with that. I would be fine with you giving me something like this. That's also okay. I would be fine if you actually put down angles that are all less than 90 and add up to 180 though, right? I'm fine with that. So if you did that, you get 2 marks. I basically look for, are you making sure both of these are being accounted for, right? Obtuse isosceles. My favorite is just to make a roof, right? And I'll just make sure this is like a 95 or something, right? And I'll just put these 2 markings down like that. I would accept that. Or you can make something like this. This is 100, and then you put down a 40 and 40, let's say, right? Because then there are 2 angles that are the same, so those sides across them would be the same as well. That's fine. So use markings, use numbers. It's your call. Okay, 2 marks for that one as well. So every one is 2 on that one. Obtuse scalene. So there you have to make it a little different. You can make an off-centered roof. This would be, let's say, 120 here. This is 30. Oh, no. If this is 30, then this has to be 30 as well. So we're going to make that 40 and this 20 or something like that. Okay. Just make sure that there's an obtuse angle there. You could have used the markings like this. That's up to you. Okay, 2 marks for that one. And then a right scalene. Just make it like this. You have the right angle there. Scalene. That would do the trick. Or put. Have you ever? Did your teachers talk to you about the 3-4-5 triangle? 3-4-5. Does that ring a bell? Some of you remember what you know what I'm talking about. Did you know that? Right, if you measure 3, 4, and this is 5, 3, 4, 5, that will be a right triangle. You can do multiples of it. Multiply everything by 2, that'd be 6, 8, 10. That's how the Egyptians would make sure that the bricks that they built would be right, like all right triangles or right angles here at this. They would measure across the brick, right? If this is the brick, they would measure across, and so they would use numbers that are easy to compute, right? At 3, 4, 5, 6, 8, 10, you know, and so forth. Multiples. Anyways, this page is 12, right? This page is worth 12. This was just an aside. Don't worry about that. 12 and 7. That's 19 total. With your name and last name on there.